Welcome to Electronics Techie. So in this video, we discuss about another modeling style of designing logic gates in Verilog. So that is nothing but behavioral modeling. So in already previous discussions, we already discussed about this behavioral modeling and what are the different styles of modeling. In previous videos, if you don't watch what is the different styles of modeling styles, then please go through that. Then you can understand what are the types and what are the modeling styles, what are the keywords you have to use like that. So in this video, we discuss the behavioral modeling of designing logic gates. So whatever the logic gates we have, so AND, OR, NAND, NOR, NOT, XOR and Xnor. These are the logic gates we have. So in this behavioral modeling, what we have to do, so in Verilog code, starting is the keyword which starts with module and end with end mode. It is same for every code. So first we have to write module. So then it is a behavioral modeling is nothing but our module name. So you have to write any name. It is like behavioral modeling style. So that's why I represent module name with behavioral underscore modeling. So no spaces between these name what you have to write. So first we have to logic gates. What are the logic gates we have? So what are the inputs? A and B are inputs. So these are the input ports. So that's why we can represent the input ports with input A comma B. So output ports with output. So why you have to write reg, I will say later. So now see what are the output ports here. So we have to design AND gate, OR gate, NOT gate, NOR gate, XOR, XNOR, NAND and NOR. So we want to design these all gates. Sorry, NAND already write here. So these are the gates we have to write. So what are the outputs for those? We don't simply write AND, comma, or, comma like that, because these are the inbuilt keywords in the Verilog. So you have to represent it with AND underscore out, because it is the output. So that's why I represent like this. So you can simply write A, O. So you have to remember that A is nothing but AND's output. O is you have to know that what is the variable you have to use for input port or output port, what it means like that. So I, for better understanding, I write AND underscore out. It is nothing but AND gate output. OR underscore out is nothing but OR gate output. Like that I have to represent all gates here. So we have to complete these port list. So by closing the square bracket and semicolon. So now what we have to do in behavioral modeling, what it say means, so always means every time. Always is nothing but in the keyword name itself, you always. So every time at the rate. So it is a, what is the inside in the bracket, we call it as a sensitivity list. So sensitivity list. So whatever you have to write in these brackets in the sensitivity list. So what you have to write this. So for it means if any change in the what are the variables we have to represent it means. So for suppose if you represent A comma B, so what I have to represent it in this sensitivity list, the variables which are used to define means whenever the values in these brackets are changed. So if A value change or B value change, then only these lines means these statements which are in the always block will be going to execute. If there is no change in the A and B values, then no use of these displaying these statements. So no need to display these all. So Verilog is simply ignore these all. Whenever there is a change in the sensitivity list means whatever the brackets you have to represent. So I have to represent star here. So what it represent means, so what are the inputs we take. So it contain all the inputs. So star represent all inputs. So now these are only two inputs. So in maybe in complex codes there are 5 inputs, 6 inputs, 7 inputs. So you have to simply write star means it represents all inputs. So no need to write A comma B comma C comma D comma E comma F comma. So no need to write all the inputs. We can simply write with star symbol. Then it means all the inputs we have. So why you have to write these at the rate means, so for controlling our sensitivity list. So while you have to represent the conditions will be changed, for controlling purpose you have to represent these at the rate symbol. So whatever the star is represent means it represent all the inputs. So it called the sensitivity list. Until now I think all you have to understand. If you have any doubts till now you can comment it. So next we have to start in always block. Why you have multiple statements, you can use begin statement. So I say that I want to say reg later. So why I have to represent these reg later means, so now see. So always and the initial blocks. So always and initial blocks are the sequential means serially executed manner means. So whatever the statements inside these initial blocks are always block that can be executed serially. But here we can see, but initial whatever the statements in the initial are always, it must should be the reg data type only, means reg data type only, not it as a wire or net data type. So whatever the data type inside the initial and always block, it must be the reg data type, not be the wire data type. So if you don't mention reg, means it simply the compiler takes output ports are the wire. So while you have to represent reg, means then only it will take as the reg. So if you don't mention here, you can don't mention that input a comma b. You simply write input a comma. What it means? So a and b are defaultly the wire data type. So if you don't mention reg, means so in defaultly these all the output variables are the wire data type. But always initial does not allow the net data type. You must and should remember that. So that's why I represent reg here. So why you have to represent reg, means this is the reason. So initial and always block never enhance or take the net data type. So that's why I represented with reg. So here these are the statements are common before as gate level modeling or data flow modeling, like that. So not gate level modeling, data flow modeling. We simply assign the values of, in data flow modeling we can use assign keyword. So here no need to use assign keyword. So you simply write end output is nothing but using symbols. For end the symbol is like ampersand, and simply or statement, and end is nothing but negotiation, and nor is nothing but end of, so or of, sorry, like XOR is nothing but cap, and Xnor is nothing but inversion of or, like. So these are the symbols we already discussed in previous video. So you can simply assign those RHS value to LHS side. So you simply begin. You have to write begin here. So that's why you stop with end keyword here. So for this module, you have to end with end module. So this is the code for behavioral modeling. This is the design code for designing the logic gates in behavioral style of modeling. So I think you have to understand why you use these always and at the rate and this star. What is the sensitivity list and what is the reg, why you have to represent reg only, not as wire or like that. So we have to all discuss here. So if you have done doubt in particular these code while are running, if you get any errors also you can comment it. So then we look into the test bench. So whatever the hardware you have to design, so logic gates we design, so whatever the gates we have to represent it with test bench, means we have to give inputs to the logic gates, then only you identify by getting the outputs whether you design the hardware is correct or wrong. So that's why test bench is needed and necessary to build a hardware while you done the code is correct or not. So that's why I have to write the test bench here. So it also same as to start with module and end with end module here. So module here also you have to represent a module name. So I simply write behavior underscore tb is my module name. So you already know that what are the inputs we have to represented, what are the inputs we take in the design code. It must be represented in test bench by reg data type or net data type. Why only we use reg data type? Now only I say the reason, means whenever you want to display any or using any variables which are in the initial and always block, that must be reg data type. So here you can see in that while test benching here I can use a b are in a initial block. So that's why I represent these a b is reg. So otherwise if you don't use anything in initial block, you can simply write wire a comma b also. But why I use reg only means, so this is the reason, this is in these statements are inside the initial block. For executing these values, so you must should represent these a comma b are the reg data type. So that's why every time we take input as the reg. So but as per the theoretical, you can mention input as reg or net data type, but because of initial block, you have to represent reg. So don't confuse on it. It must be maybe very useful to you. Why and what are the outputs? It should be represented with net data type. So that's why I represented y. So you can represent all the gates here and end with semicolon. So next whatever you have right here means, so what is the module name here in design code? You have to represent design code module name. It is design code module name. So you have to instantiate properly, otherwise if you don't mention properly means these inputs are not preferable to design code. So by writing correct these instantiation only, these test bench will connected to this design code, otherwise there is no connection between these two. So it was the instance name here. You already say that most in Verilog we use DUT and design under test and UUT like that. So if you no need to mention these two only, you can use any name. That's why represented like this. So for your understanding, no need to mention particular thing. So you can use anything. That's why I represented here. So this is the port connection. Port connection, how you can connect ports are already discussed. If you don't know, then go to previous video and and you can see properly, then you can understand what is the port connection. There are the two styles in port connection, that is by name and the order. So mostly we prefer name because there are so many ports here, so no need to confuse like that. So if you have less number of 1 or 2 3 ports like that, so you can go with order. So otherwise it is better to take name, ports connection by name like that. So now after port connection, then we can start initial. So multiple statements are there, so that's why I take begin. So I can initialize the values for a, b, and after 5 seconds delay, then I take a is equal to 0 and b is equal to 1. After 5 seconds, then I take a is equal, so like that I take 4 combinations, because 2 variables that then I got 4 combinations. I represented 4 combination here. So after 5 seconds delay, then I finish, means why we write finish means for stop the simulation, for stop the stimulation for that particular period. No need to continue the time period like this. So I have to finish that. For this begin statement, for this begin I use this end keyword here. So for if you want display anything, then initial begin you can display anything. Then why I write these 4 lines, I already say I use EDA Playground, which is online platform. If you don't know about this, if you want any how to use and how to simulate in this EDA Playground, so you just comment it. I say how you use like in separate video. If you know, then ignore it. So end module is end with end module. So why I write these 4 lines means for simulation purpose. Because of writing these 4 lines only you get the waveform, otherwise you can't get waveform. So that's why I wrote these 4 lines. So this is the waveform of the final output we get. So simply there is a AZ. So here there is a white line C. So whenever these mark here, so that values is represented here. So no, don't be confused. If you want these values, so then simply move this white color line to this first place or second place, where in which point you want. So you can simply move that like that, then you get proper output waveforms for particular values like that. So okay, let's go. So here the white line, so that's why I represented like this. Here a is equal to 0. Here we can see, okay, a is equal to 0 and b is equal to 0. So the output of the end underscore out is nothing but 0. So I take 0 0 combination here. Maybe I don't double click here, that's why the previous values of these waveforms is simply there. So don't be confused. I just verified these, so the output waveform may be correct. So if you want these values, so simply take these values. So a is equal to 1 and b is equal to 0 here. So for that I can write the outputs and or not, nor, Nand, XOR, Xnor. So 1 0. So for AND gate 1 0 combination we get 0. So for OR 1. Not inversion of 1 is nothing but 0. So NOR means we get inversion of OR. So 0. So AND is nothing but inversion of AND gate. So 1. So XOR is nothing but there is a different values, that's why we get 1. So Xnor is nothing but 0. So now see the values is correct or not. For AND gate it will be 0. So here see the output will be 0. Okay, correct. So for next one, NAND gate. So NAND gate output is nothing but 1. So here the output will be 1 here. So you see here the output will be 1. So next gate will be the NOR. So NOR will be the 0. So here the C, it is the 0, logic 0. So you can represent it here. So next one is not output is nothing but 0. So it is also represented with 0. So next R out, so R value is 1. So here we can see it's like this. So it is logic 1. So Xnor is nothing but 0. So you can see it is the lower one. So logic 0. So XOR is nothing but 1. So here that is represented with 1. So I don't double click here. That's why these values, the whatever these values is doesn't updated here. So the previous values in this line it will be shown here. So if you double click properly, then these values are represented here, these in left side of your waveform. So you can clarify it. So if you have any doubts, you can comment it. No need to bother about anything like that. So if you want about EDA Playground, then also you can comment it. If you have any doubts, Testbench or design code, you can simply mention your doubt in your comments. Until then, bye.